I'm Anil Kumar. Welcome to my series on vectors. I'm sharing with you some excellent questions from previous test papers. Here is question number 11, which is three persons are standing on a plane. The first person is standing at the origin. The second person is standing at an elevation of 2 meters higher, 6 meters east, and 5 meters north of the first person. The third person is standing 3 meters below and 4 meters west of the first. Determine the Cartesian equation of the plane. If the fourth person is standing 5 meters east of the first person, are all four people standing on a plane? So these are the two questions based on the situation given to you. I'd like you to pause the video, answer the question, and then look into my suggestions. Now let's try to sketch the position in R3. So we'll assume that this is north, right? And that will be our east. So that is along this plane, and higher means we'll go like this, correct? So that is what we are going to look into, right? So we'll say this is north for us, this is east for us, and that is up, right? So, but when we translate it to our plane equation, that is x, y, z, in that case, you will see that we normally take y in this direction, right? So we'll say j in this direction, right? We'll take I in this direction. And the unit vector k towards up. Does make sense to you? So we are actually going to use these unit vectors to find the position of each and every person. The first person is given to us at the origin itself, so that becomes 0, 0, 0. So that is our person A, right? So we are given here that the position of A is basically 0, 0, 0. So that's the coordinate position, right? So we'll call first person as A. The second person, we'll call second person as B, which means second person standing at an elevation of 2 meters upright, which is going to be positive. So this is going to be 2 higher, right? 6 meters east, that is along the Y, so we'll take this as 6. And 5 meters north, now this is going in the reverse direction of I, so I'll take this as minus 5. It's kind of important to define your structure and then solve it. So that is how we get the coordinates of the other person, right? With respect to the first person who is at the origin. The third person is standing 3 meters below. So C is the third person. 3 meters below means minus 3, right? 3 meters below. 4 meters west means minus 4 for Y. Of the 4 meters west of Y. So only these 2 points are given to us. So that means this is 0 along the x-axis. So we have the 3 positions of the people. Now these 3 positions could give you vectors directions, right? So we could get what AB is. So A to B will be B minus A. So we could get this as, so when you do this, you could get this as minus, so B minus A will do. So we get minus 5, 6, and 2, correct? So that is AB for us. Now let us also find what is A to C. So A to C will be this position vector, which is 0, minus 4, minus 3, correct? So it's a good practice to write them in a matrix, row matrix form, so that these are now our vectors. To get the equation, we need to find the cross product, correct? So the next step for us will be to find cross product between AB and AC. This cross product will give you the normal, correct? That will give you the normal. So to find the cross product, minus 5, 6, 2, one way is we can find matrix and do it. The other way is we can write this as 6, right? 6, 2, minus 5, and then again 6. This is for AB. And then we have here minus 4, minus 3. 0 minus 4. And then, we can just get all the coefficients by taking these as positives and the other ones on the other side as negatives, correct? So that way we get our position vector, right? So, the normal vector. So in this particular situation, so what we get here is 6 times minus 3 is minus 18 minus 4 times 2, which is plus 8, right? So that is along I. Now along J, we get 2 times 0, which is 0, and then we get negative of this, minus this is plus, so we get minus 15. That is J, right? And plus K, the coefficient K will be minus, and minus becomes plus 20, and that is 0, right? So plus 0 K. So that gives you the normal vector n, correct? So from here we get normal as equal to, we can add this up, so we get minus 10I, and here we get minus 15J, and here we get 20K. Correct? So that becomes our normal vector. You could actually divide them all by say 5, because they are scalar multiples. So you could also write this normal as, you can take actually minus, let me say, I could take minus 5 common, correct? Let's take minus 5 common. So we get 2I plus 3J minus 4K. Is that clear to you? So we could do that. So that is our normal vector, right? And therefore, we have our equation, which will say the plane equation will be given to us as minus, this is not 2I, 3J, and 4K. So we could write this as 2X, right, plus 3Y minus 4Z, right, equals to 0. Now the value of D is basically 0, since one person is at the origin. So we are considering the point at the origin. How did we get this? We get it from the form, which is the Cartesian form, AX plus BY plus CZ plus D equals to 0. Now, so D equals to 0 since we have A at the origin. So we have origin as one of our points. So if I substitute 0, 0, 0, I get D equals to 0. Got it? So that is how we get our scalar equation. Perfect. So we got the first part, which is the scalar equation part. So let me rewrite the answer for that. So the answer for the scalar equation is 2x plus 3y minus 4z equals to 0. Right? So that is our part A. Now let's do part B. Part B is the fourth person is standing 5 meters east of the first person. Right? So just 5 meters east, right? So in this direction. So that means the location of the fourth person could be 0. 5 east means that is positive, and this is 0. Is it okay? So we'll substitute these points and then just check, right? So we need to check if the point 0, 5, 0 is represented by this plane or not. So when you substitute these values, what do you get? You get 2 times 0 plus 3 times 5 minus 4 times 0. Now this is equal to how much? This is equal to 15, right? Now since 15 is not equal to 0, so fourth person is not in the same place. Is that clear? So that is how you are going to answer this question. I hope that's absolutely clear, right? So basically, we began with the coordinates. We defined our coordinates. Once we got that, we got our directions. Those are our 2 directions, right? And then they're cross-multiplied to get the normal. We use the standard Cartesian equation. which is of the form of ax plus by plus cz plus d equals to 0. Now, since there is a person at the origin, we say d equals to 0, right? 0, 0, 0 is a point in our plane, right? So d is equal to 0. Distance from origin is 0. And then we can actually find the solution. I hope you find it interesting and useful. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.